Hello, and welcome to today's session. As always, I'm your host, Kevin Grote, Staff Systems Engineer here at VMware. And today we've got our third session with Mr. Steve Toomey. Steve is a storage specialist, VSAN specialist here inside of the storage BU at VMware. And today, Steve is going to be talking about the current state of architecture with Virtual SAN 6.2. So this is going to include things like all flash and hybrid arrays and different types of RAID, what it means. This can be a little more technical, but it's a great session. Steve really knows what he's talking about. So be sure to watch this session. Also check out the other ones. He's got a great one in here on cost modeling and the introduction of VxRail. Also a great way to talk about and kind of introduce some of the architectural conversations. And we also have some fantastic sessions covering the VSAN assessment. So how to get started before you make some of these moves, make some of these architectural decisions, and start looking at what hardware you're going to put it on. So without anything further, let's go ahead and listen to Steve tell us a little bit more about the current state of architecture with Virtual SAN 6.2.
So how does this work? And again, actually, this is outlining how that mirror actually works. So when a virtual machine has a virtual machine file, a VMDK file on the VSAN data store, that VSAN data store natively replicates that data between two nodes. Well, one of the things that I'd like everybody to know is that we're not actually using RAID. So when you think of RAID, you think of disks, and that is exactly what RAID means, a redundant array of independent or inexpensive disks, depending on who you ask. We're actually using what's called a RAIN model. So we're actually using a redundant array of independent nodes. So when I write data to my virtual SAN, I'm not writing it to multiple places on one node. I'm actually writing it across to 2 or 3 or 4 nodes, depending on what structures you're using. So you get benefits that each node now becomes a failure. If that node number 1 fails, node number 2 still has an entire copy of the data, or in this case, node number 3 actually has the entire copy of the data. So that virtual machine is not interrupted. It's still completely available from a data perspective. All of its data is still there. The virtual SAN is still providing that data up and down, so reading and writing. So there's no interruption in service if you lose a host out of the virtual SAN. So we do have 2 modes. We have hybrid, which is flash layer for caching, and then magnetic disks for capacity. We see a lot of this with infrastructures where you have your bring your own, your build your own mentality, or they have existing infrastructure already that they want to roll into virtual SAN. And I can tell you from my own experience, our all flash offering is really where we're selling most, if not all, of our new installs. With the current pricing of all flash and our dedupe and compression of getting probably around 2.5x, we are actually seeing most, if not all flash configurations being less expensive, and that's including the licensing, by the way, than hybrid configurations. So, and again, we do support 1 gig, even though 10 gigabit Ethernet is preferred. As VMware supports 25, 40, and beyond, we will also support those technologies from a networking. They will significantly decrease latencies and stuff like that, even beyond what 10 gig does. So again, RAIN architecture, node-based failures, failure domains per se, that is the heart of virtual SAN. The other piece of this, and one thing I really need everybody to understand, is that virtual SAN is a synchronous technology. There is no difference between node number 1 and node number 3 in this particular case. When that virtual machine writes data to the virtual SAN, that virtual machine does not get an acknowledgement that that write has been completed until both copies have been written. So again, if you have a failure of node number 1, the virtual machine is uninterrupted on the virtual SAN data store because node number 3 has the exact same data that just went offline on node number 1. So there is no interruption. There is never a chance for corruption of data or a missed transaction. So virtual SAN synchronous, very powerful. If you go to an all-flash configuration, that opens up RAID 5 and RAID 6 for you. We're considering what we're calling erasure coding. Again, this does require an all-flash architecture. From a licensing perspective, this does require VSAN Advanced. So you do need both of those, all-flash and VSAN Advanced. But in this particular case, you're actually breaking the data apart across 4 nodes as opposed to 2 nodes. And what this provides is a tremendous amount of space savings. So in a mirror situation, I literally have 2 times my data that's being consumed. So if you have 10 terabytes of storage raw, you're actually only able to consume up to 5 terabytes because I have to double copy everything. If you're using RAID 5, you actually get 75%, because you're only actually doing 1.3 times the data as opposed to 2. So your actual return is a much, much higher return on that. So again, RAID 5, tremendous space savings, tremendous space giving back to the customer for utilization so that they can utilize it. And believe it or not, because it is on the all-flash architecture designed for the random I/O that RAID 5 produces, the performance hit of using RAID 5 is actually very, very low. It's in the realm of 3 to 4%. So it's not a high performance hit, but it is a tremendous capacity increase.